Building a helicopter for Mars is nothing like building one for Earth. The air is 99% thinner. Gravity is weaker, and you can't control it in real time. Today, I'm breaking down the exact engineering logic behind designing a helicopter that can actually fly on Mars. Let's start with the core problem: lift. On Earth, rotors push against dense air. On Mars, the atmosphere is only about 1% the density of Earth's, which means a standard helicopter becomes basically useless. To generate lift in such thin air, you have only three options. 1. Make the helicopter extremely light. 2. Make the rotor blades very large. 3. Spin them insanely fast, around 2,400, 3,000 RPM, which is roughly 6 to 10x faster than an Earth helicopter. Gravity helps a little because Mars gravity is about 38% of Earth's, but it's still nowhere near enough to compensate for the thin air. We're talking less than 2 kilo. Carbon fiber is the only realistic choice. Every gram matters, because a heavier body means larger rotors, more power consumption, and more failure points.